Hello everyone. Today we will discuss about a specific topic which is the purity of the matter. Actually, in the matter there are three types of states: solid, liquid, gases, and different types of components. Okay? Sometimes this is pure, sometimes this is in the form of mixture, and in the pure substance there is also element and compound. So there are different types of terminology, and we will discuss about these different types of pure, mixture, element, compound, etc. The first of all, I will discuss about the pure substances. Pure substance contains actually single type of component, and this can be element or compound. In the element substances, element is a type of pure substance which cannot be broken in the simpler form. Okay, and when different types of elements are combined, the substance is called compound substance. Compound substance contains different types of elements. Okay, and in the element there are metal, non-metal, metalloid. Actually, the element which is malleable, ductile, and can flow the electricity is called metal. What is the term for malleable? Actually, metal can be hammered in the form of thin plate. And what is ductile? When the metal is converted into a wire, this is called ductile. Okay. Now, gold, silver, etc. are metals. We know that. And chlorine, iodine, bromine, these are non-metals. Actually, non-metals are not malleable, are not ductile, and can never conduct electricity through it. So this is non-metal. Sometimes there are some specific characters, not metal, not non-metal. The transition form of these two, metal and non-metal, is called metalloid. Actually, germanium is a type of metalloid substance. Okay, now I will tell about the mixture. Actually, mixture substance contains different types of pure substance. So this is the basic difference between compound and mixture. Compound is pure substance, contains different types of elements, and mixture is not a pure substance. Mixture contains different types of pure substances. Okay, sometimes these components are uniformly distributed. There is not present any type of boundary. So this type of mixture is homogeneous mixture, such as solution. Solution is a type of homogeneous mixture where a specific type of component is dissolved into another specific type of component. Okay, sugar solution, salt solution, and when the components, pure substances, are not uniformly distributed, is called heterogeneous mixture, and there is specific boundary we can notice. The mixture of salt, sand, the mixture of sugar, sand, these are heterogeneous mixture. Colloidal solution, suspension are all heterogeneous mixture. Okay, we will know about solute and solvent in the solution. Actually, the component in which solute is dissolved is called solvent. The component which is dissolved into the solvent is called solute. The main information is that the solute is dissolved into solvent. In sugar solution, sugar is dissolved into water. In salt solution, salt is dissolved into water. These are the main components of solution, and there are two types of solutions. Number one is saturated solution, number two is unsaturated solution. The solution in which there is no increase in the amount of solute in the solvent, the specific type of solution is saturated solution. There is ultimate amount of solute in the solvent. No extra solute can be dissolved into the solvent. This is called saturated solution. But in unsaturated solution, the amount of solute present in the solvent is below the saturation level. So this is unsaturated solution. In unsaturated solution, extra amount of solute can be dissolved into the solvent. Okay. Then we will notice, first of all, we should know the Tyndall effect. What is Tyndall effect? The particles are large enough to scatter the light beam when light is used in a specific types of solution, and the particles in the solution is large enough to scatter the light beam. Okay, I will tell you by a specific diagram. Here is a light, and these are the particles and the light beam. This is large particle and the light beam is scattered in this way. This another particle, the light beam is scattered in this way. This is called the Tyndall effect. But in solution, the particles are so small, there is no scatter of the light beam. So Tyndall effect cannot be found in the solution. And when we keep the solution undisturbed, the particles does not settle down. Okay, the particles are not separated by the filtration process in solution, but in suspension there is big difference. Solution versus suspension versus colloidal solution. In suspension, the suspension is heterogeneous mixture and the particles in suspension are large enough to scatter the light beam. So, in suspension, Tyndall effect is found. And lastly, the suspension is kept undisturbed and the particles settle down. The particles can be separated by filtration process. Okay. Now in colloidal solution, actually this is also a heterogeneous mixture and the particles are also large enough to scatter the light beam in such a way. So Tyndall effect is also found in the colloidal solution. But if it is kept undisturbed, no particle settle down and finally it cannot be separated by filtration process but by the centrifugal process. So actually I am going to discuss about the specific types of separation processes to separate the components in the mixture. Okay, first of all I will tell you evaporation. Evaporation process is found to separate the volatile and non-volatile components, and I will tell you a specific example, that is the seawater. In seawater, the water is actually the solvent and this is volatile component and the salt is non-volatile component. The salt is solute here. When seawater is kept under the sunlight, the volatile water is converted into gaseous substance. Water is evaporated. Evaporation process, you know, the water is evaporated and the salt is left behind. In this way, the evaporation process is used to separate volatile and non-volatile components. Okay, now I will tell you about the centrifugal process. This process is used to separate the colloidal solutions. In centrifugal machine, there is high rotation, and by this high rotating machine, the colloidal particles are separated, are left behind. Okay, and there is another process called sublimation. I told you what is sublimation. This is directly interconversion between solid state to gaseous state, and this is found in ammonium chloride, the volatile component. When there is a heterogeneous mixture of ammonium chloride and salt, the ammonium chloride is volatile component and salt is non-volatile component, and by the process of sublimation, ammonium chloride is converted into gaseous substance. The sublimation process occurs for the volatile component called ammonium chloride, and the non-volatile component salt is left behind. Okay, this is the main process, sublimation. Now I will tell about the chromatography. First of all, please notice this figure, this basic chromatography figure, and this figure I will tell you what happens. There are two types or more than two types of solutes. These solutes are actually very much different in the solubility. Actually, what happens, the solutes are dyed with different types of colors. This is a red color, this is a green, this is a red color, and this is the green color. And first of all, I should tell you that this green color solute is with high solubility, this red color solute is with low solubility. Okay, now what happens, the solute with high solubility can be soluble in the water very fast and it rises in the water very fast. So green color solute in this way goes higher very fast, and on the other hand, red color solute with low solubility can be soluble in the water in low rate. So it rises in the water in low rate also. So this is the diagram. This is high solubility and this is low solubility. It rises fast and it rises slow. Okay, by this way, by the process of chromatography, different types of solute with different solubility, with different dye can be separated in one solvent. Okay, by this way, the chromatography is the process to separate the components of the mixture. Then I will tell you distillation and fractional distillation. Actually, these two processes are used to separate the two types of miscible liquids. Okay, the process is goes on the vaporization followed by the condensation, the interconversion from liquid to gas, and followed by the interconversion between gas to liquid. Okay, when the temperature becomes above 25 Kelvin, it is called vaporization. When the temperature becomes below 25 Kelvin, the process is fractional distillation. Okay, for distillation, the temperature should be above 25 Kelvin. For fractional distillation, the temperature should be below 25 Kelvin. This is the main difference between these two processes, only in the temperature. Finally, I will tell you the last process to separate the mixture components. This is crystallization. When in seawater is used for the separation process by crystallization, what happens? The water is converted into ice cube. The water is crystallized here and the salt is left behind. So this is the main specific topic to separate the pure substance from the impure substance. Okay, in this way crystallization occurs. Okay, by evaporation, salt, seawater are separated. By crystallization also, salt, seawater separated. But by crystallization process, this is the best way to get the pure salt. Okay, now I will tell about the last portion of our discussion. This is a main portion, a big topic called purification of drinking water. How we can drink simply pure water. First of all, there are some steps. Sedimentation followed by loading, followed by filtration, and the last step is chlorination. By sedimentation, the specific suspended unwanted particles settle down, and after that the alum is used. The loading of alum occurs. Alum is positively charged and the clay in the drinking water actually negatively charged. This clay and alum, positive and negative, are combined and then are coagulated and finally settle down. After that, some extra unwanted particles can be separated from the water by the process of filtration. And finally, our main purpose to get rid of bacteria. The specific process is called chlorination. By chlorination process, the water can be free from bacteria, and after these steps we get a pure drinking water. This is the whole process of purification of drinking water. So this is all about the matter and its purity, and the specific portion of our discussion was the separation process of components of mixture, and lastly the purification of drinking water. I hope this whole discussion is going to be useful to your study. If you have any questions, please write down in the comment section. And if you like this video, please subscribe YouTube Knowledge Flame channel, and obviously download Google Play Store Knowledge Flame app. Thank you.